Today's lesson is on radicals and rational exponents. So, dividing rational exponents, we need to remember what a radical symbol is. And a radical symbol is simply just the square root sign. So you probably just call it the square root sign and not the radical symbol, but it actually has a term associated with it. And that sign is used to indicate when you have to take the square root of something. A radical expression is when we have an expression that's containing one or more radical symbols. And remember, an expression is a problem without an equal sign. And in this case, a radical expression can't have an equal sign, but it has to have at least one radical symbol, if not more. Okay. Just a reminder here that when we have a power to a power, that we multiply the exponents. So that's a review from last year. We're going to show you how interchangeable exponents and the square root works here. So we want to solve for k. We want to figure out what is the value of k in this case. So we have to cancel that square root sign out. So in order to cancel a square root sign, we have to take the square of it. And if we do it to one side, we have to do it to the other. So the square root sign and the square cancel each other out, and you're left with 4 here. And over here, that's the product of powers. We have a power to a power, so we're going to multiply them. So we have the 4, the base, and we have k times 2, or 2k. And now looking at this, if we have the same base and they're set equal to each other, so for example, if I just use x, if I have x to the m power equal to x to the nth power, then the m and the n have to be equal if x to the m is equal to x to the n. So what's going to happen here is these 4s are just going to go away. And this first 4 doesn't have an exponent, but it's really a 1. We just never write that. So if I use this little rule over here, I can simplify this down to just the exponents of 1 equals 2 to the k power. And then I can use an upside down t to solve. This is 2 times k, so the opposite would be to divide by 2. And I'd be left with k on this side and 1/2 on this side. So if I go back to my original problem, they're telling me that the square root of 4 is equal to 4 to the 1/2 power. So those are interchangeable. That's going to be useful information later on when we get working on some of the problems. Over here, we have the same situation going on, but we have a cube root. And a cube root simply means something 3 times. So in this case, the cube root of 8 means what do we multiply by itself 3 times to get the number 8? Okay. So with that being said, we have to solve for k. So to cancel out a cubed root, I'm going to have to cube it. And that will cancel out. If I do it to the left side, I have to do it to the right side. And the cube and the cube root and the cube will cancel out, and we will be left with 8 on this side. And on the other side, our base is 8, and we have to do k times 3, or 3k. And that same rule applies if we have the same base and they're set equal to each other, then their exponents have to be the same. So the 8 really has an exponent of 1, and the 8 on the right-hand side has exponent of 3 times k. So if I upside down t and 3 times k, the opposite would be to divide by that 3. So I'm left with k equals 1/3. So going back to our original problem, the cube root of 8 is going to be equal to 8 to the 1/3. So quickly looking at those two, we're looking at this and we're looking at this. If we have a square root and we make it into a fraction exponent, the bottom, the denominator of that fraction is a 2. Square root is 2 what can we multiply by itself twice to get that answer? So our denominator is 2. A cube root is what can we multiply by itself 3 times? So our denominator over there is 3. So you don't have to do all of that work. You just need to remember that little hint in your head. All right. So simplifying expressions with radical exponents here. So the general rule is that a number raised to a power of 1 over n is going to be equal to the nth root of that number. So this is what we just showed in the last slide there. This is just the generic definition of it. So right here is exactly what I said. So if I have b to the 1 over n power, that's going to be the same thing as the nth root of that number. So down here I have some examples. Let's look at this one. We didn't talk about 1/4. So b to the 1/4 is going to be the 4th root of b because the denominator is 4 and the numerator is 1. Okay, so then over here in this column, I have the same examples. I just have them written with actual numbers that work out. So the square root of 25, what times itself is 25? Well, the answer is 5. The cube root of 8, what times itself 3 times is going to give you 8? Well, that would be 2 because 2 times 2 is 4, and then times another 2 would be 8. And then the 4th root of 81 is what times itself 4 times would give you 81, and that would be 3. If we multiply 3 times 3 times 3 times 3, we would get 81. All right, so example, they want us to simplify each of these expressions. So 16 to the 1/4 power. So we just talked about how we take that denominator, and that is what is going to go out here. So we're going to have to do the 4th root of 16. So what times itself 4 times is going to give you 16? Well, if I have to multiply something 4 times, it's going to have to be quite small. So let's start off by trying out 2's. 2 times 2 times 2 times 2. Well, 2 times 2 would give us 4. This 2 times 2 would give us 4, and 4 times 4 would be 16. So the answer is, what did we multiply together 4 times to get 16? We did 2. So the answer to the 16 to the 1/4 power is 2. The next one is 125 to the 1/3. So 3 is our denominator, so we're going to have to do a cubed root of 125. So I have to multiply something together 3 times to get 125. And guess and check, I'm going to start off with a little bit bigger number, but not too much, because when we're multiplying, they grow pretty quickly. I'm going to try 5. So 5 times 5 times 5. We need 3 of them. So 5 times 5 is 125. Oh, sorry, not 125. It is 25. And then I multiply that by that extra 5, and I get the 125. So what did I multiply together 3 times? I multiplied together 5. So 5 is our answer here. 125 to the 1/3 power is really 5. This one, they're going to involve a couple of them. So 49 to the 1/2 power. 1/2, that would be a square root, so we don't need to write that 2 out front. The square root of 49 plus the denominator of this one is 3, so this one's going to be the cubed root of 27. So the square root of 49 is 7, because 7 times 7 is 49. And the cubed root of 27, that would be 3, because 3 times 3 is 9, times 3 is 27. And we're adding. So 7 plus 3 is 10. So the answer to that problem would be 10. All right, 1,000 to the 1/3 power. So the denominator is 3. So that's a cubed root of 1,000 minus 64 to the 1/6 power. So we would be doing the 6th root of 64. So what can I multiply together 3 times to get 1,000? That would be 10. 10 times 10 is 100, times another 10 would be 1,000. And then 6th root of 64 would be 2. So 10 minus 2 would be 8. So the answer to that whole problem is 8. Using properties with rational exponents. I put all of the properties that we had talked about in 8th grade here on this one slide for a reminder of the different rules, because those are going to come in handy while we're working with these exponents here in Algebra 1. So the first one is the product of properties, which we when we are multiplying. So if I have the same base, I want to add our exponents. So that would be a to the m times a to the nth. We're going to keep the a and we're going to add exponents. So that shouldn't say product of property right there. That should say the multiplication. That's the multiplication. Property. We're going to add. The quotient of powers is division. So I guess I shouldn't cross these out. I'm just rewriting them with words that you remember. Remember, product is the answer to multiplication. Quotient is the answer to division. So they're still called those, but they work with division. So if I'm dividing and I have the same base of a, and I'm going to subtract exponents. So I'm going to take that top exponent and subtract the bottom exponent. When I have two numbers being multiplied together inside of a parenthesis and then raised to a power, I can separate those. I can distribute that exponent to both numbers inside of the parenthesis or both variables, whatever you have. So a is to the nth power and b is to the nth power, and then we can multiply them. The next one here is division inside of the parentheses. So I'm right here. The same thing works out. If you have an exponent outside of the parentheses, you're going to distribute it to everything inside the parentheses. So you're going to have a to the n over b to the n. The only thing here is b can't equal 0 because we can't have a 0 at the bottom of a division problem. So that only works if b is not 0. And then product of powers we talked about, or power of power. We have two exponents. The rule is multiply those two exponents. Keep your base, multiply your two exponents. And then our negative exponent, in order to make it a positive exponent, here we are going to make a fraction. So we put 1 over and then that base to a positive exponent. So whenever we have a negative exponent, it's really going to be a decimal answer or a fraction answer. So we put that in fraction form. All right, so I'm running out of time for this free video. So what I'm going to do is make a second video with the next examples.